wave theory doesn't explain black body radiations and a photoelectric effect. Photoelectric effect. These two parameters was not explained. So in order to explain these two parameters only, we are going to discuss about the Planck quantum theory. Okay, Planck quantum theory. So Planck quantum theory, what simply is saying that the energy coming from any source, okay, the energy coming from any source, from any source comes discontinuously, comes discontinuously in the form of small packets, in the form of small packets called quanta. That means energy which is there, no, that will come discontinuous, like this is one packet, and this is one packet, this is one packet, and this is one packet. Like in a discontinuous manner, the light or anything can be comes, and these small packets only we are calling it as a quanta. Okay, these small packets only we are saying that quanta, and he is saying that the energy of this quanta, the energy of this quanta is directly proportional to directly proportional to frequency. That is E directly proportional to mu. So E directly proportional to mu means what we can say, E equal to, by removing this constant we will use some constant, no, that constant we are saying that h nu, where h equal to what, Planck's constant. Planck's constant, and the h value is 6.625 into 10 to the power of minus 27 erg second, or h value will be 6.625 into 10 to the power of minus 34 joule second. Okay, so these are the 2 points we can say. And see, and one more relation we know, no, that is C equal to nu lambda. By the combination of these two, nu can be written as C by lambda, right? From there what we can write, E equal to hc by lambda. And as we, this is one formula, okay, and one more formula we know, that is E equal to hc nu bar also we can write. How? As we know, nu bar equal to what, 1 by lambda, right? So these are the formulas and questions we can solve on this one. Planck quantum theory. Based on this Planck quantum theory, what are the points we can say? For example, if I want to calculate 1 2 questions on this, okay, if I want to calculate 1 2 questions on this, simply we can calculate. Okay. See, for example, let me solve one question on this. Question is, 100-watt bulb. This is previous year question. Bulb emits Monochromatic light of wavelength. Monochromatic light of wavelength 400 nanometers. Calculate the number of photons emitted uh, per second by the bulb. Anyone can answer this. Please answer if you know how to approach this question. You are open to speak. Feel free to speak. Have you understood what to do, what is given?
Yes, sir.
Tell me how to do, Nana. I think everybody knows Telugu, I think. So please speak. మీరు మాట్లాడాలి, ఓకే? మీరు ఇంటరాక్ట్ అవ్వాలి. సో ఇంటరాక్ట్ అయితేనే సో దట్ ఐ క్యాన్ ఐడెంటిఫై అండ్ I can go. Should I solve more questions or less questions? I will get one clarity.
Sir, can we use E equals to HC by lambda?
Yes, okay. Why we can use E equal to hc by lambda, Nana? Please tell me. Formula correct, Nana. Why?
Because we
Because
have
see,
given the 100 watt and 400 nanometers and
100 watt
wavelength.
means what? He has given the total energy emitted by the bulb. Okay.
We have
So
given wavelength equals to 400 nanometers.
yes, power watt means what? 100 watts. So 100 watts means what? 100 joules per second. So this is the energy of the bulb. Okay. So this is the energy of the bulb. Whereas what we need, and he is saying that it is emitting a photon wavelength is, that means one photon. One photon means a small quantum, I said, no? One photon wavelength lambda is given 400 nanometers. So convert into meters, because h value we are taking in joules, no? So convert into meters. So nanometer equal to how many meters? 10 to the power of minus 9
10 to the
meters.
power of
That
minus
means
9.
4 into 10 to the power of minus 7 meters. And from that one, energy of one photon can be calculated. Energy of one photon will be how much? Equal to E equal to hc by lambda. That means h value 6.625 into 10 to the power of minus 34 into c value. Let me write like this. So from there, E equal to what we can say, h value 6.625 into 10 power of minus 34 joules into c value 3 into 10 to the power of 8 meters per second by lambda, how much it will be? 4 into 10 to the power of minus 7. Minus 7 plus 7? Minus 7 meter. So that we will get energy per joules we will get. So if we are calculating this, what is the value we will get? 27 plus 88. So 6.625.23 means nearly 20. Okay, 20 by 4, 19.985 something we will write. I will take it as 20 into minus 27 plus 8. That means 10 power of minus 21. That will be 5 into 10 to the power of minus 21. Okay, 5 into 10 to the power of minus okay, minus 21. Therefore, what we can say, number of photons is equal to what we can say, total energy, that is 100 by 5 into 10 to the power of minus 21. So 5 ones are 520. That means 20 into 10 to the power of plus 21. That means 2 into 10 to the power of 20 per second. Okay, around I am doing. Okay. Okay, students.
Yes, sir.
So this is what we can say about the uh, photoelectric effect and sorry, photoelectric effect not Planck quantum theory and one question based simple question. Okay, and the next one is so after this and c equal to u lambda, this will not useful. Okay. Next one is photoelectric effect. Everybody getting what I'm trying to say?
Yes, sir.
Photoelectric effect. Okay. Photoelectric effect means, so simply we can say it is uh, the ejection of electrons from a from active metals when light falls on the surface. That means, for example, if I'm taking this is the metal surface. Okay, so when light is fall on this, when light falls on this, then what we can say from here, electrons are going to eject. Okay, this ejection of electrons phenomenon only we are saying that photoelectric effect. So how photoelectric effect can be explained? For example, say whenever light is, for example, say this is the active metal. No, active metal means what, like uh, potassium, sodium, cesium. These are all the active metals. Okay, so whenever light on each and every metal, okay, each and every metal having a characteristic wavelength or frequency which is known as threshold frequency, we can say. So that means what we can say, whenever each and every metal, it will have some frequency which is known as threshold frequency for the ejection of electrons. Means what we can say, every metal has a characteristic frequency called threshold frequency. So this threshold frequency is fixed for each and every metal. That threshold frequency I'm indicating with the nu naught. Okay, na? So for example, if I'm taking the sodium metal, it will have some certain frequency, and potassium metal, if I'm taking, that will have certain frequency. That we are saying that threshold frequency. If the incident light, okay, if the incident light has greater frequency, greater frequency than the threshold frequency, then ejection of electrons takes place. Ejection of electrons takes place. That means what we can say is, for example, say, so this is the metal if I'm taking. Okay, like CCM metal if I'm taking, let me take. So its threshold frequency is 100, let me take 100 seconds, we can say. Okay, what is the frequency unit?
Hertz.
Hertz, no? So let me cycles per second. Okay, 100 hertz, let me take frequency. And if the incident frequency has, which is greater than 100 hertz, then electrons can eject, otherwise cannot eject. Understood what is the point I said? Okay, so this is the meaning of the point. If the incident has greater frequency than threshold frequency, then ejection of electrons takes place, otherwise not. For example, okay, if this say on the same metal, if I'm using 150 hedges of energy, if I'm using, okay, if I'm using 100 hedges of energy, if I'm using, then what will happen? Tell me what you can observe. So definitely ejection of electrons will take place. Then what will be the remaining 50? For the ejection of electron, I need only 100. And what about the remaining 50? That is the question. That means, okay, from the incident energy of, from the uh, incident energy of light, okay, from the energy of incident light, some quantity of energy, some quantity of energy is utilized for removal of electron. Because some quantity is utilized for removal of electron. That energy which is utilized for the removal of electron is known as work function. Is known as what? Work function. Okay, so that means what? Some quantity will be utilized for the removal of electron, and remaining quantity remaining quantity is utilized as kinetic energy of ejected electrons. That means what we can say, on the metal surface, some quantity of energy will be utilized to remove electron, and some quantity will be utilized for the kinetic energy of the electron. That means what we can say, uh, the total energy incident, which is equal to remove, that is work function plus kinetic energy of ejected electron. Kinetic energy of ejected electron. That means what we can say, total energy E equal to work function we will represent with W naught plus kinetic energy half mv square, and energy E equal to what we can write, H nu, and work function can be written as H nu naught plus half mv square. Okay, this is formula. From there what we can say, kinetic energy is equal to H nu minus H nu naught, where nu is frequency of incident light, and nu naught is the frequency of threshold frequency of the metal. Okay, na students, these are the photoelectric effect and their phenomenon. And here two more points are there that you need to remember. The point is, uh, greater the frequency of greater the frequency of greater the frequency of incident light so greater the kinetic energy of ejected electrons. For example, say this is the metal. Okay, let me take cesium metal, and this is also cesium metal. This is also cesium metal. Three cases I have taken, and in all cases, the threshold frequency is 100 hertz, and here also what threshold frequency is 100, and here also 100 hertz only. And here what I am taking? Here I am taking the incident energy have 150 hertz, and here what we can say 130 hertz, and here let me take incident energy have 110 hertz. Now see, in all the cases to remove the electron we need 100 hertz of energy only, but here see, and remaining 10 will be kinetic energy, and remaining 20 here, sorry, 30 will be kinetic energy, and remaining 50 will be kinetic energy. That is when I said greater the frequency of incident light, greater the kinetic of ejected electrons. And one more point, greater the intensity of incident light, greater the number of ejected electrons. Okay, so this is what we can say about the photoelectric effect and their points. Okay, so now if I want to solve um, let me solve one example on this. The question is the threshold frequency am I going fastly, students, or okay the speed okay, or should I reduce,
It's okay,
should I
sir.
slow down?
Okay, sir.
Okay, sir.
Okay, the threshold frequency mm, for a metal is for a metal is 7 into 10 to the power of 14 second inverse. Calculate the kinetic energy of an electron emitted when radiation of frequency when radiation of frequency V equal to 1 into 10 to the power of 15 second inverse. Please try to answer this, Nana. How to solve this? Tell me how to solve this. Students, please respond. Are you solving or what? చూడండి నేను
Yes,
సాల్వ్
sir.
చేస్తాను
Solving.
నేను సాల్వ్ చేస్తాను చూడండి. సో threshold frequency given, that means nu naught is given, that is 7 into 10 to the power of 14. Therefore work function ఏమవుతుంది, work function will be equal to h nu naught, no, that is h value will be 6.625 into 10 to the power of minus 34 into 7 into 10 to the power of 14. So 6.625 into 7 means around okay, ఎంత అవుతుందమ్మా, it is make it 6.6, 6.6 into 7, 42. Okay, 7 6 42 46, 46.2. Let me take it as 46 into minus 34 means minus 20, and energy incident equal to h nu, that will be same 6.6 to 6.6 into 10 to the power of minus 34 into 1 into 10 to the power of 15. That means what we can write, 6.6 into 10 to the power of how much we can write,
19, sir.
19, no? Make it is 66 into 10 to the power of 20. Both will be same, it will become, no? Therefore kinetic energy means what we can say, energy incident minus work function, no? So energy incident will be 66 into 10 power of minus 20, and minus work function will be 46 into 10 power of minus 20. That means 46 minus 66 means 20 into 10 power of minus 20 around. Okay. So likewise only we need to solve, we don't have any option. Okay na? So if you want to solve, sir, I will solve simply, sir, I will solve and I will go detailed this, we can't go. Okay na, students?
Sir, can you explain one?
Actually see what is given for the function, threshold frequency given. Threshold frequency means what, nu naught given, and incident frequency given, and asking kinetic energy. We know, no, energy incident equal to work function plus kinetic energy formula. From there what we can write, kinetic energy equal to energy incident minus work function, no? Just now I said. So first I calculated work function, that is 6.625, I have taken as 6.6. Okay na? So by taking rounding off, so from there I calculated this value, and energy incident, that is h nu I calculated, that is how much I got, this much. So kinetic energy equal to energy incident minus work function. Okay na? Likewise only I did. Can I go for next slide?
Yes, sir.
Next concept is hydrogen spectrum. Okay, hydrogen spectrum. Hydrogen spectrum is what we can say simply. Okay, hydrogen spectrum is what we can say simply. See, so in the hydrogen spectrum generally, when we are observing hydrogen spectrum, no, we are having different different series of spectral lines. Okay, so in hydrogen spectrum, what we have? We have different series of spectrums, spectrals. That only we are saying that no Lyman series, Balmer series, bracket series, fund series. Okay, that we are saying that Lyman series. For example, Lyman. So when it is the ground level from which it is exciting, that I'm taking as N1, and excited level I'm taking as N2, and a region I'm going to write like this. So in Lyman series, what is N1 value? 1, and N2 value will be 2, 3, so on. And the region is known as which region it is? Lyman series you will observe in which series, Nana? Ultraviolet region, no? Lyman. Next one, Balmer. Balmer series N1 ground level is 2, and the highest level is 3, 4, 5. I will. So this will be observed in visible region. Lyman Balmer. Next, Parsons series. Ground level is 3, and higher level will be 4, 5, 6, like that. So this will be observed in higher region.
Sir,
Next,
it will start from 5, 6 and 7, no sir, Pichon.
where? Where 7, Nana? Students, can you please repeat?
Pichon, sir.
Region.
After Blammer, it will Pichon, no sir. It will come from 5, 6, 7, no sir.
No, no, Ocha. Parsons series, no, sorry. Parsons series, it will come from 4, we will write. Okay. 4, 5, 6. Next higher level it is. Okay, na? And bracket series, we will write 4. From there, N2 will be 5, 6, 7, like this. And next one, fund series. In fund series, N1 value will be 5, and N2 value will be 6, 7, 8, so on. This is also in higher region. This is also in infrared region only. This only you are asking, you are saying, no? Next, see, Nana. Next one, N1 and N2 this, no? So can we calculate the spectral line? What is the formula, wavelength or wave number for the calculation of spectral line? Which equation it is? Rydberg's equation, right? From Rydberg's equation, what we can write, that is nu bar equal to 1 by lambda equal to RH into 1 by N1 square minus 1 by N2 square into Z square for hydrogen like atoms. And here RH is known as Rydberg's constant. And the value is 109,677 centimeter inverse. Okay, students. This is what we can say about the Rydberg's equation. And next one, to calculate the total number of spectral lines. Okay. The formula for total number of spectral lines. Number of spectral lines. Any idea formula? That is n into n minus 1 by 2, where n is the highest level. Highest level. And if there are 2 spectral lines are there, one more formula is there. Number of spectral lines is equal to summation of n2 minus n1 also there. Okay, summation of n2 minus n1 also there. For example, question they had given like calculate the number of spectral lines when transitions taking from eighth level to third level. That means if an electron is there which is at eighth level and it is coming to third level, that means what? It can come 8 to 5 or it can come 8 to second or 8 to third. So like that, how many transitions we are going to find? Then in that case, what can be the answer? That is summation of 8 minus 3. That is summation of 5. Summation of 5 means what we can say? 5 plus 4 plus 3 plus 2 plus 1. That is 9, 12, 14, 15. That means if an electron jumps from 8th level to third level, there will be 15 type of spectral lines can be possible. Okay, now students. Next one. See, in any series, if electron jumps from infinite level, that means what we can say? n2 equal to infinite. That spectral line is called limiting line. Okay, limiting line. That means if n2 to infinity means what we can say? That will be limiting line we can say. Whereas first line means what we can say? Third line, immediate line. For example, let me take uh, Nana. Let me take, this is infinite level. This is first level, second level, third level. If electron jumps from first to second level to first level, or it can jumps from third level to fourth level, or it can jumps from fourth level to first level. Similarly, it can jumps from fifth level to first level, and so on. It will go for infinite level to first level. This is known as first line. Okay, first line. That is also called as H alpha. This is second line. This is H beta. This is third line. This is H gamma. This is fourth line. That is H delta. H gamma, H delta. And this is limiting line. Now see, as the transitions are taking place for ground line, this all belongs to which series we can say? Lyman series we can say. That means in any series also, the first line is called H alpha, second line is called H beta, third line is called H gamma, fourth line is called H delta, and the last line is called limiting line, naito least line we can say. Understood now what I'm trying to say? Students, have you understood?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so based on this, problems will be continued tomorrow. Okay, We will discuss the problems on this topic tomorrow, and we can go for Bohr's theory and their formulas, etc. We can derive, right? Good night, students. And if you are having anywhere any issue is there, no, so please let me know. Okay. Thank you, all of you. Bye. Good night.
Thank you, sir.
Thank you, sir.
Thank you, sir.